In this video, I want to do a couple more examples of related rate questions. A balloon leaves the ground 500 feet away from an observer and rises vertically at a rate of 140 feet per minute. At what rate is the angle of inclination of the observer's line of sight increasing at the instant when the balloon is exactly 500 feet above the ground? So I've drawn the picture here, and you can see I could label this like X and Y, but I know what X is. That's 500. The observer is not walking to or from the balloon. So, he is 500 feet away. Okay? So this is my picture. All right, let's write down the rates that we know and the rates we want to know. Well, I know what dy dt is. That's 140. If you wanted to put dx dt, you certainly could. Dx dt is the rate at which the length x is changing, and that's 0. That's not changing at all. And we're looking for the rate at which the angle is changing. Okay. So next we need an equation. Well, because we're involving an angle, we really do need the trig functions. You have a choice of what trig function you want to use. I usually use the trig function that involves the sides that I've labeled and that I know, and that would be, in my case, tangent. You certainly could use sine or cosine, but I like to use, as I said, the sides that I was kind of given. Okay. Now, I'm going to do something a little bit different in this that I didn't do in the previous video. In a previous video, I said, well, x is just 500. That's unchanging, and therefore I am going to put 500 in right now. I'm actually going to do this derivative without plugging 500 in, just to show you that even if the man was walking to or from that kind of point where the balloon took off, we could still do this problem. It actually would not add a whole lot of work to it. So I'm going to leave it as y over x, but you certainly could do y divided by 500 here because we know that this is static and unchanging. Okay? Let me do the derivative. Derivative of tangent is secant squared d theta dt. Now y over x, because I've left it as x and not put it as 500, I need to use quotient rule. So we're going to have low d high minus high d low, cross the line and square the low. Okay. Now, as I go to the substitute and solve step, let me maybe do a little bit of that even right here, just kind of writing things above. I know that x is 500. I know that dy dt is 140. I know that y is 500, and I know that dx dt is 0. And in the denominator, I know that x was 500, so it's being squared. Okay. Now, of course, this 500 multiplied by 0 is 0. So I end up with 500 multiplied by 140 divided by 500 squared. Well, 500 divided by 500 squared is just has a 500 in the denominator. So all I have left in the numerator is 140. And all I have left in the denominator is 500. That reduces to 14/50ths or 7/25ths. So very nice little reducing there. Now, as I said, we didn't have to do quotient rule because we could have put 500 in for x. But this does show you that even if x were changing, the man was walking to or from, he was walking with a rate to the point, or he was walking away to get a better view of the balloon or whatever, we could still easily solve this problem. Okay? I like to do that right side first. Now, secant squared, I need to do something to replace the secant squared. So here's what I'm going to do. I'm going to go over to my triangle. I'm going to label it. Okay, at this point, this is 500. You could use Pythagorean theorem, 500 squared plus 500 squared, and square root that. It comes out to be 500 square roots of 2. Okay, if you want to use your 45-45 triangle rules. So I'm going to start, because it's secant, I'm going to start by looking at cosine, because that's the reciprocal of secant. So cosine is adjacent over hypotenuse. Okay. Now, hopefully you see a reduction I could make. I'm not going to make it quite yet, okay, because I kind of want to keep this in the look that it is. So secant is the reciprocal, so just flip it. So secant squared, of course we would just square this. Now I want to make this, okay, 500 divided by 500 is 1, so that's gone. The square root of 2 squared is just 2. So I can replace secant squared with just 2. I still have d theta dt. Dividing both sides by 2, same as multiplying by 1/2. So d theta dt is 7/50 radians per minute. All right, the altitude of a triangle is increasing at a rate of 1 centimeter per minute, while the area of the triangle is increasing at a rate of 2 square centimeters per minute. At what rate is the base of the triangle changing? Well, first of all, let me just, hopefully you remember that altitude is the same as height. Okay, so I'm going to put that because, of course, our area is always base, half the base times the height. Okay, so my picture, I've got a triangle. Label the base, height. Okay. The rates I know quite a few actually. I know the rate at which the height is changing. It's +1, positive because the height is getting bigger. I know dA dt, the rate at which the area is changing. Again, it's positive because, centimeters, not meters. Positive because it's getting bigger. A little sloppy here with my writing, I apologize. And I'm looking for what rate the base is changing. So equation, we got to use the area, half base times height. Now, as I go to do the derivative, of course, derivative of A is dA dt, that's not a big deal. But over here, base times height, they are both changing. They're both changing quantities. We were told how the height is changing, and we're wondering how the base is changing. Because of that, I need to use product rule. I'm going to do that in parentheses here. First, multiplied by derivative of the second, plus second, multiplied by derivative of the first. Like that. Okay, let's start substituting in everything we know, solving for what we don't. 2 equals 1/2. I don't know the base yet. Let me just leave that right here. Okay, dH dt though I know is 1, plus the height they told me was 10, and I'm solving for dB dt. So I do need to know the base. How I could do that is I could use the fact that the area is 100 when the height is 10. Okay, so let me just kind of do that right over here in a little corner. So 100 equals half the base multiplied by the height. So 100 equals 5b, so b is 20. Okay, so I can substitute that in right here. And I'm just going to continue right here where I got a little room. I can multiply the 1/2 through. 1/2 of 20 is 10 plus 5 dB dt. Subtract 10 from both sides. Divide by 5. So dB dt is -8/5 centimeters per minute. Now, one thing that kind of throws people is that it comes out to be negative. And why that is because the height is increasing at a rate that would increase the area more than 2 square centimeters every minute if the base we're left alone. So the base actually needs to kind of collapse in to offset how fast the height is growing.